it's Mr. Murray coming to you with a Do Now for Course 1 Honors for Tuesday, June 16th, 2020. So in this Do Now, what I want you to do is I'm giving you 4 equations or inequalities. And for each, I want you to find its solution. So the first thing we need to do is the absolute value of 3x minus 2 plus 6 is less than or equal to 4. The second is 36n squared plus 84n plus 100 equals 51. The third is 3x cubed plus 3x equals 0. And the final one is 5 times 3 to the power of x squared plus 3x plus 5 plus 27 equals 162. Okay, so please take a moment, pause the video, solve these inequalities or equations, then when you're ready, unpause, and you can see what I got. Okay, folks, so let's get started. First, I'm going to do the inequality. All right. So for the inequality, I have the absolute value of 3x minus 2 plus 6 is less than or equal to 4. So the first thing we need to do is we need to get Barcelona. So we have Barcelona. We have an absolute value being less than or equal to a negative number. This tells us there are no real solutions. Moving on down to the next one, right? And by the way, remember, an absolute value can't be negative, so it can't be less than a negative. Okay, so the next is 36n squared plus 84n plus 100 is equal to 51. So remember, this is a quadratic equation. The first thing we're going to do is set it equal to 0. By subtracting 51 from both sides. Now I factor because of the presence of a b value. And what I'm going to notice here is that these are both perfect squares. 36n squared is 6n times 6n, and 49 is 7 times 7. So I'm going to try 6n, 6n, 7, and 7. And I'm choosing a positive because I see a positive here. I'm not saying it'll work. I'm saying a lot of times it does, so it's worth a try. Sorry, 42. And 42 plus 42 is 84. Perfect. So 6n plus 7 squared equals 0. So n equals negative 7/6. All right, moving on down to the next one here. 3x cubed. So this one seems like it's a cubic at first. Like what would I even do to solve this? Okay, so what you want to do is you want to start by looking for anything that you can factor out. And you can see that these both have a 3x in them. So I factor out a 3x. This becomes x squared because 3x times x squared is 3x cubed plus 1. So essentially, I need to look at what makes this 0 and what makes this 0. So what makes 3x 0? Well, x is 0. What about x squared plus 1? Well, there are no real numbers that make this true because we know that when you get squares alone, you have to take the square root of a negative number. However, we do know that technically the square root of negative 1 is defined as plus or minus I. So I would take x equals 0 as the only solution, the only real one. Or you could say x equals 0, x equals I, x equals negative I. Or even x equals 0 and then x equals plus or minus I. Also acceptable. All right, last one is exponential. So here we need to get squares alone, or powers alone, bases alone, whatever. So remember, that's the idea behind today's do now, is it's the alonas. We had bars alone, we just did squares alone, now we have bases alone. So I've got, right, we just want to get the 3 stuff by itself. Okay, so this is equal to 135 divide by 5, and what we should get is 27, and that's exactly what you want, because 27 is a power of 3. So we rewrite 27 as 3 cubed, and then by the one-to-one property, because the bases are the same and the expressions are equal to each other, the exponents also have to be equal to each other. So now I'm going to go x squared plus 3x plus 2 equals 0. So I've got x plus 1, x plus 2. So either x is negative 1 or x is negative 2. Okay? If x is negative 1, right, you're going to see you get 3. And if x is negative 2, you also get 3. So this had 2 solutions. Usually these only have 1. The reason this had 2 solutions was because I put a quadratic in the exponent, so you had to solve a quadratic to finish out the problem. So folks, hopefully you're able to get these right. If so, congratulations. Please make sure you're continuing with the final week activities. Best of luck. Don't forget to love math. And remember, you can do it.